So in this video, we're going to calculate a product chain, or the product of, which is just the product of three or more matrices. So here it says compute the product A times B times C. So if we lay out A, we get 1, 3, 2, negative 1. And then times B, and B is the 2 by 3 matrix, 0, negative 1, 1, 0, 3, negative 2. And then C is a 3 by 1 matrix, 4, negative 1, and 0. And so what we see here is we have a 2 by 2 square matrix being multiplied by a 2 by 3 matrix, which is being multiplied by a 3 times 1, 3 by 1 matrix. And this product is going to exist because the inner numbers match. The 2 matches the 2, and here the 3 matches the 3. So for example, if we did A times B first, we would wind up with a 2 by 3 matrix. If we took this product first, we would get a 2 by 3 matrix. And we would be able to take the next product because we have a 3 by 1 matrix and these inner numbers would match. And we would wind up with a 2 by 1 matrix when we were done. Remember that multiplication is associative. So we can change the grouping. We could say, hey, I'm going to do this multiplication first. So if we did this product first, we know it exists because the inner numbers match, and we would wind up with a 2 by 1 matrix. We would wind up with a 2 by 1 matrix, and then multiplied by a 2 by 2 matrix, the inner numbers would be matching. We'll wind up with a 2 by 1 matrix. So the idea is, because matrix multiplication is associative, we can choose to take this product first or this product first. If we take this product first, the product of these two matrices will be a 2 by 3 matrix, which is still kind of large. If we take this product first, we'll wind up with a 2 by 1 matrix. And it might be easier to multiply a 2 by 2 matrix by a 2 by 1 matrix. So if I were doing this one, I probably would choose to do this product first. So if we do that, I'll just drop down my other matrix. We get 1, 3, 2, negative 1. And then when we take this product, we're going to get a 2 by 1 matrix. So we're going to get a 2 by 1 matrix. And so that's 2 rows and 1 column. So it's just going to be row 2 times, or the dot product of row 2 with column 1. And then we'll take the dot product of row 2 with column 1 to get our 2 by 1 matrix. So the dot product here would be 0 times 4 plus 1 times negative 1 plus 3 times 0. So 0 times 4 is 0, plus 1 times negative 1 is negative 1. Negative 1 plus 3 times 0 is just a negative 1. And that takes care of row 1, column 1, and then we get row 2, column 2. So we take the dot product of row 2 with column 2. Negative 1 times 4 is negative 4, plus 0 times negative 1 is 0, plus negative 2 times 0 is 0. So we just get negative 1 times 4 is negative 4. So we wound up with that. We wound up here with a 2 by 1 matrix after we took this product, and then we would just take the product of the 2 by 2 times the 2 by 1, which will give us, because this is 2 by 2 and this is a 2 by 1, we're going to wind up with a 2 by 1 matrix when we're done. So it should just be a little guy here. So we'll take the dot product. It's going to be 1. That's row 1, column 1. So 1 times negative 1 is negative 1, plus 2 times negative 4 is negative 8. And here we get 3 times negative 1 is negative 3, plus negative 1 times negative 4 is positive 4, and then we just need to simplify. Negative 1 plus negative 8 is negative 9, and negative 3 plus 4 is 1. So again, in this case, because it was a product chain, a product of multiple matrices or more than 2 matrices, we had the ability, because of the associative property, to choose the product that we took first. And then I chose my product based on the fact that it looked like this product here would give me a simpler matrix to work with in my next product.